wonderful to be here. It's kind of exciting, actually, speaking after Meg. I've been in the industry about 35 years now, been at HP 17 years. And I think Meg is by far the most ambitious, dynamic, and probably one of the neatest executives I have ever personally met, and is an inspiration for the entire senior leadership team. So what you see is the real thing, and she's pretty dynamic. Anyway, I'm here to talk to you about Moonshot. I actually won what's called the Hyperscale business unit, and that's responsible for working with the largest service providers. And it was out of that we actually got the inspiration for Product Moonshot. By understanding the next generation, the new style of IT that's emerging. And I think Meg did a good job of setting this up. I think this is probably one of the largest revolutionary changes in IT that's going on now. Meg talked about all the various trends that are affecting this. Big data, mobility, social networking. And that's going to change fundamentally the type of applications for not only the large web service providers, but for every single corporation that's running IT. And it's an opportunity for you to use this as a competitive advantage. And at the same time, we have a power problem. Every one of the data centers that we build takes the equivalent power of 250,000 European homes. The new data centers are putting online about 7,000 servers a day, 35,000 square feet of data center space a day. And so that's creating a real challenge. As we have a thirst and a desire for new capabilities, especially around mobility, we have a serious situation from what are we going to do in regards to the planet. And that's our answer, is Project Moonshot. What we've done is we've created a revolutionary new server designed for the at-scale applications using ultra-low energy servers to save power, cost, and space. So let's talk about that. It's a revolutionary new server design because this is the first time in many years that we designed a system that wasn't a general purpose server. As you know, we've been designing general purpose servers, and there's become a footprint in the industry. Those general purpose servers are running general purpose software. And this is the first time we broke that. This is a new design. We broke down everything into its raw components, and we designed application-specific servers and server cartridges. And each one of those cartridges is really focused on a specific type of workload. And that's very different than what we've done before. And we've architected it in a way that's very different from what we've done before. The second thing, it's designed for at-scale applications. It's designed for the applications that are scaling, that are being used in volume. So it's important to understand what Moonshot is for and what it's not for. If you need one server to run a SQL database, that's not what Moonshot's for. If, however, you have a major application that you run that's mission critical to your business, it may be appropriate for you to use Moonshot. And so we're going to talk a little bit about that today. The third thing is it uses new types of devices. Typical servers are designed to be able to get every bit of power out of that device. The devices that we're using in Moonshot actually come from the notebook and the cell phone industry. And that's an important distinction because those devices were designed to run on batteries. And when you want to be able to run a device on batteries all day long, you design it differently. You architect it differently, you construct it differently, you use different fab processes, different types of transistors. Everything is done different so that you can get the most amount of power out of the smallest amount of charge. And those are the devices that we fundamentally use. We use a larger number of more energy efficient devices. And the big thing is, by doing so, we can reduce cost, power, and space. And not by a small amount, not by 5 or 10%, but by very dramatic amounts. This is a Moonshot server. It's got its own CPU, memory, disk drive, own Ethernet ports, completely independent, can be managed differently, independently, and we put 45 of these into this chassis. So in 4.3U, you get the equivalent of 45 complete separated servers, connected together in a converged infrastructure. And what it looks like overall in the chassis itself is we've got the system itself, and that system itself has got shared power, shared cooling, shared fan, shared infrastructure, shared management. The entire system is managed with a single point, one management interface. So what you effectively get is 45 servers connected together, working together as one. Then we have shared fabrics that interconnect these devices together. We have shared Ethernet, so you have common Ethernet, including the switches that come out. There's shared communication ports so that these devices can not only talk external to the world, but they can communicate with each other as a community to do some really interesting next generation types of tasks. And those connections allow connections of storage and allow connections of complete fabrics. All of the cartridges are connected together, so you can even do a high-performance technical computing interface and have a small blast radius within that, a toroid, so to speak, connecting all the cartridges together. So it opens up all kinds of new opportunities, new programming opportunities, new applications that can take advantage of a system like this in ways that we've never been able to do with general purpose servers. So it's an exciting and a revolutionary new opportunity. The other thing that we're doing is we're designing application-specific cartridges. This is the first one. And we have an entire roadmap of cartridges that will be coming out. And each one of those application server-specific cartridges will be tuned and focused on a new type of application. And that allows us to fundamentally change the TCO equation instead of using a general purpose server. So there will be times you'll want to use a general purpose server, but there'll be other times where Moonshot will offer you TCO advantages, power advantages, reductions in power, reductions in space, reductions in total cost that will be dramatic enough that you're going to want to look into it for that type of application. And from a management standpoint, we looked at this totally different. Since I can put 45 servers into that chassis, and that gives me the ability to put 450 servers in a rack, when you think about how you manage those, you fundamentally have to do it different. In fact, one of our customers gave us a challenge. He gave us the challenge he called the Million Core Challenge. And he said, how can you give me the capabilities and the tools to be able to manage 1 million servers, because that's how many I'm going to have in my infrastructure in the future. And if you think of that problem, it really fundamentally changes how you have to look at things. We looked at our current ways of discovery with typical management tools. Typical ways of discovery with IPv6, our calculations said to go out there to the network and discover all the IP ports would take 11 years with 1 million servers. Probably not practical. The other thing is you don't want to have to go out to 1 million servers and say, hey, 1013, are you okay? What does it look like? Are you running the right firmware? Right? So what we did was really take a different paradigm shift and said we need to look at this whole number of servers as a community and then look for who's operating differently than everyone else. And we took some of the technology that we had from our high-performance technical computing clusters, where you run 1,000 or 2,000 or 3,000 nodes all the same way, and use that fundamental technology to provide a way to manage the entire infrastructure. So that way you can look at an entire group of servers and say, which ones are acting the same and which ones are different? Tell me which one is getting packet errors on the Ethernet. Tell me which one is running over temperature. Tell me which one fundamentally has the wrong firmware compared to all the others. And that tool that does a difference versus an individual one-on-one management gives us the ability to look at the servers and manage a large number very different. So the one thing I get asked a lot is, wow, Moonshot is really cool. That looks neat. I have no clue what I'm going to use it for. I've had some people say, I'm going to buy one, and I don't know what I'm going to use it for. But fundamentally, let me give you a couple of things that we've heard from customers who are looking at the systems now. And I think this would be pretty interesting. First, LeaseWeb. If you look at a typical host provider, and LeaseWeb is a host provider that provides web services, an individual dedicated server for all of their clients to run their particular website. They have entry level, they have mid-tier, and they have high performance depending on how much traffic and what that web tier looks like. For their entry level, they're taking a dedicated one-use server that's barely idling and running that particular application for that customer, right? Typically a website, maybe something that's not served very actively. So what they're going to be using this for is as they deploy those entry levels, they feel that they can use Moonshot because the cartridge is perfect for an entry-level server, and it gives them the ability to have better packing density and lower overall power. Their typical 1U 2P server powers up around 120 to 160 watts. This Moonshot server in their application is under 15. So they go from under 15, or they go from 150 to under 15, and overall in the entry level, where they're really price competitive, the difference in the savings from the power is enough for that to be worthwhile for them to go deploy in a new era. So they're actually going to be deploying Moonshots for that entry-level web tier. Second customer example is Airbus. Airbus has an interesting problem where they have 20,000 users that access a central site because they have, as you know, Airbus manufacturers from multiple different companies that do wings and engines in different parts of the system. So they're spread out all around Europe. So the challenge that they have is providing a clean interface for all these remote users to be able to call into, be able to access, and then they want to be able to run some applications locally and then be able to spawn other applications out to run on high-performance technical computing clusters. So they're actually testing right now, piloting, and plan to roll out Moonshot as that front-end interface so that each one of their remote productivity users comes to a Moonshot server, and that server is their interface then that runs some applications locally and then spawns out to high-performance technical computing tasks for the others. Third customer, there's a large bank who prefers not to be mentioned by name that has a particular problem in that they have to provide information and security access to particular parts of their portfolio as a result of access from governments. To do that, they actually have to parse all of their data into a red zone, a yellow zone, and a green zone. To run that application takes 40 individual servers, and by law it's required that each one of those servers is not a virtualized machine. It has to be a dedicated machine that's completely independent that runs on its own IP port. So for them, they were going to have to deploy 40 servers in a rack at every POP location to run this security application. And instead, they looked at Moonshot and said, based on the application, we can put the entire application into 45 of those servers, run each one independently, and therefore be able to just install one Moonshot system instead of having to do a rack of 40 systems clustered together. And overall, that gives them an easier way for them to deploy that. Fourth example is HPIT. Meg kind of stole the thunder here. HPIT actually is a very large site. It runs about 300 million hits a day. It's an incredibly complex website. Okay? And they started off with a crawl, walk, run philosophy. When they first got started with Moonshot, they had their doubts. They were actually running HP Unix machines in there. They brought Moonshot in, and they were pleasantly surprised because they used an Nginx reverse proxy server, and they were able to take off and run a very amount. They were able to run 15% of HP.com almost immediately on 6 cartridges. So they were able to quickly scale up from that to be able to run a much larger site. I'm not going to go through the details of that one. If you look at where we're going, the first solution is based on Intel Avoton. It's an Intel Center, based on Intel, I'm sorry, the first design is based on Intel Centerton, which is an Intel Atom type device. It's a 2-core device that operates at about 2 gigahertz. It has about 8 gigabytes of memory. Now, when we release the next generation of cartridges, what we're calling Leap 2, that come out later this year, we're going to be doing a substantial upscaling to the capabilities of the cores. Intel's next release is a product called Avoton. And Avoton is an 8-core device that runs well over 2 gigahertz, and we'll be putting up to 32 gigabytes of memory on the cartridge. So that means that we'll have a system that will be pretty powerful overall in terms of its core capabilities. So 45 Avoton in one chassis. Now the next thing beyond that in Leap 2, the next cartridge, is actually what we call a quad cartridge. This device is compute heavy. So you can see we removed the storage from it, and it's got 4 discrete servers on board. That means 4 nodes, 4 servers, each with its own IP address, each with its own memory. And then when we plug this into a Moonshot, suddenly instead of going from 450 in a rack, we can go to 1,800. That's 180 servers in every Moonshot chassis with incredible capability in terms of power. So what we're seeing is because everything is densifying, everything is turning into SoCs, and more capabilities are coming, what we're able to do is provide capabilities to be able to put a tremendous amount of power and compute capabilities into a very small frame that's managed together as one holistic solution. Now, some other interesting things that you can see is that as we add some of these new cartridges on, they open up new opportunities for new types of workloads. The first one is Avoton. Although Centerton is more based for static web sites, Avoton has got enough compute power for it to be able to handle very powerful sites, being able to do complete dynamic web access. We have a cartridge that's coming out from TI. It's called the TI Hawking. And it's based on 4 ARM cores, and it's got 8 integrated DSPs. And they're all connected together as one fabric. Now, the DSPs allow us to go after a new type of workload: seismic processing, voice analysis, voice detection, all kinds of things where DSPs are powerful. And that will give us an opportunity to create new types of solutions. After that, we have a cartridge coming out that's a quad cartridge that uses a device from AMD called Keynote. And this is one of AMD's aggregated CPU and GPU devices, which they call it an APU. And that opens up the opportunity to do all kinds of things around video encoding, video decoding, video enhancement, HDI, new solutions like that. Where you can see from an HDI standpoint, instead of having to virtualize, we can now put 180 nodes into one Moonshot chassis, 1,800 into a Moonshot rack, to be able to provide a compelling way for you to provide virtual terminal services without having to worry about any degradation in quality of service because of sharing multiple nodes across one VM. So it's a new way to look at it. It's kind of moving more from a virtualization when you do HDI to a physicalization. We have a lot of other cartridges that are coming up that are working on new workloads. Unfortunately, I can't go beyond Leap 2 without an NDA. So if you'd like to hear more of some of the advanced cartridges that we have, we'll give you that opportunity by just meeting with your account manager. But we do have solutions that are going after FSI, going after all kinds of new workloads, and really increasing the power yet once again. The cool thing about the way we've designed this is really, since we've designed the infrastructure and the chassis once, we can now bring a variety of solutions out very rapidly. The cartridges themselves are easy for us to design, and we actually partner very well with the industry. So we have multiple partners that are working on cartridges. They can sign off on an MPA, and that gives them the opportunity for them to develop cartridges and become true partners with us in a very fast route to market. So it provides us an opportunity to go a lot faster. I'll give you an example. TI received their next generation Hawking DSP in December. In January, we had it laid out on a Moonshot cartridge. In February, we had it powered up and running the operating system. And in March, we had it in our Discovery Center, which is a place where customers can remotely access devices and solutions to try out their workloads. Now, this is a very different kind of server than your general purpose server. And it requires a combination of working much closer with you as a customer to make sure that we have the right cartridge and the right solution for what workload you're targeting it at. But the exciting thing is when we do that, what we find is the TCO advantages, the advantages in terms of power, density, cost, space, everything are so dramatic that customers look at it and say, this is worthwhile. Because to save 5% wouldn't be worthwhile to move to a new type of architecture, but to save 50, 70, 80, 90% on not only cost, but power efficiency and space is pretty disruptive. So it's a new thing for us. We're pretty excited about it, and we think it will really make a difference. If you think back to when the first PC server came out in 1989, it was really leveraging the volume economics of the desktop market space. And that's what we're doing once again. What we're doing is leveraging the mobile space and leveraging the cell phone space to take those devices, which are growing in volume, and leveraging those devices into a new space to do a new server that's fundamentally revolutionary, different than anything we've done before. And I can remember when we first launched the PC servers, there were a lot of people who said, hey, you know, it'll be a long day before I ever run a PC server. Did anyone ever say that? Maybe, right? You were stuck on HPUX or you're stuck on mainframes or whatever. And now look at how many people have transitioned and what the percentage is. We believe this is one of those inflection points. The first cartridge might not be the right one for you, but we believe that this is an inflection in the industry similar to the PC servers. And as we ride the volume economics, and as devices change, as disk drives become more solid state and then become more on die, as revolution changes, as voltage regulators come off board and come on board, we believe that fundamentally everything will be shrinking down so that servers will become an SoC. And we've developed the architecture that allows us to put them together, to be able to manage them, power them, connect them, that we believe is going to be a disruption in the industry. So it'll be interesting to see how this plays out, but we're really excited about Moonshot, and that's kind of the direction that we're going. We believe it'll be a revolution, and that it will change how we look at computing in the next generation. Thank you.